Hi everyone, it's Nono Martinez Alonso here, and this is livestream 86. I want to welcome you to one more day of the Nono.ma livestream, in which we take a look at creative coding and machine intelligence algorithms and try to solve different problems to learn about different things. And we also do things that have to do with the Getting Simple podcast. Today, I'm going to continue the exercise that we did last week that had to do with decision forests. This is TensorFlow Decision Forests Python package that is developed by the TensorFlow team. And I'm going to try to finalize that exercise on classification of penguin species. We were using an open source data set for that and an existing Google Colab notebook. And we're going to take a look at a few things that have to do with Docker. And if we get time, also with TensorFlow signatures. So stay with us if you want to take a look at these things. And I'll encourage you to also like this video if you're enjoying the content that I'm doing on the live stream, and to subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. You can also join us on Discord, right? We have the Discord community or Discord server at Nono.ma/Discord. And without further ado, we're going to get started. Last week, we saw the first part of Decision Forests. We didn't have time to finish going through the notebook. And, my hope was just to see an overview of how that example works. And we're going to try to build up on some of those concepts today as well. And just a reminder, we have new Getting Simple podcast episodes coming, and you can submit questions about the last or any other previous episodes at gettingsimple.com/ask. You can either submit a video recording of yourself or just an audio recording that you can submit from your computer or from your phone. All right. So what are we doing today? Today, as I said, we're going to take a look at decision forests, and maybe if we get time, we might also take a look at some other things that have to do with TensorFlow signatures and Docker. So let's get started with this part, right? So this is Decision Forests Part 2, live stream 86, in which we're going to continue working on the notebook that we started working last week. I have a link that I'll put on the Discord live channel, and you can catch up from wherever we left it today. And just a quick intro here. TensorFlow Decision Forests is a Python package or a Python library developed by the TensorFlow team. So it's an official library. And you can access it at tensorflow.org/decision_forests. You can see the URL down there. They define this as a library to train, run, and interpret decision forest models in TensorFlow. For example, like random forests, gradient boosted trees, and others, right? So I was a bit confused because the topic or the name decision forests doesn't really exist, I think, on the literature. Is more random forests or decision trees, but I think they mixed a few things here and they named their library that way for that reason. It's often referred to this library as TF-DF, right? And that's how we will import it in Python as TF-DF. And yeah, I'm not going to read the slow letters that I put there, so we're going to keep going. And here you have like the example that you can see. The first thing that they show you on the on their website. We're gonna zoom in and we can see that the thing, and you can see the bank there. So this arrow bank here, that means that this is running inside of a Python script or a Python notebook, and it's trying to execute a command line, probably bash command. In that command, they're installing the TensorFlow decision forests with pip install TensorFlow and TensorFlow_decision_forests. You can see the installed TensorFlow. This is TensorFlow core. This is the desktop library. And this is the package that I'm talking about, right? TensorFlow Decision Forests. And later we import the Decision Forests model or like library as TFDF and pandas as PD. I assume we're not using TensorFlow here, but TFDF actually depends on TensorFlow, so TensorFlow is also going to be used here in some way. We load the dataset in a Panda data frame. We convert the dataset into a TensorFlow dataset with the PD data frame to TensorFlow dataset. So this is a Panda data frame to TensorFlow dataset. Then we train the random forest model with the random forest model. We instantiate it and then we feed it with the trained data. We get a model summary, we evaluate on the test dataset, and then we save the model to the save model format. This is, in a nutshell, similar to what we did last week, but like a more summarized example where the dataset is already prepared. We don't visualize anything of the dataset and we just get going really quickly, right? And just commenting on the dataset that we were using, I didn't comment too much last week. This is a dataset called Palmer Penguins. This is an open dataset that is intended, let me actually look at the description, as an alternative to Iris, right? Is provided as a great dataset for data exploration and visualization. And they offer things like the build length, the build depth, the island to which these penguins belong to, their species, and other data. I think their height and maybe also their mass, right? Their weight. There are three classes or three species that we're classifying or trying to classify between. One is the chinstrap, the Gentoo, and the Adelie. And visually they look, you can recognize them visually. And this is a table that compares the big length to the flipper length. And you can see like those lines are kind of like the average or the mean that we're classifying for. And this says dimensions for Adelie, chinstrap, and Gentoo penguins at Palmer Station, LTER. I don't know what LTER stands for, but that's the Palmer Penguins dataset. And yeah, I think this is it for what I have in terms of taking a look at or an overview of what we did last week. Next, I'm going to open the Discord server and I'm going to go to the live channel. So I'm going to click here. I'm going to go to the live channel and we have the links posted in here. So we're going to look at the Palmer Penguins dataset. So we can see that one here. Okay. Right. So let's take a look at this one first. So this, as I said, is an alternative to Iris. And you can see things on how to, let's say, inspect this data set, right? You can see this is the source from which I got the information that I put on my slides today. Another link that I provide here is the TensorFlow Decision Forests link. So this is the information I showed before. And if you go to guides and tutorials, the beginner collab is the one that walks you through the exercise with the penguins, the Palmer Penguins dataset, right? We got, I think, up to this point last week. So we got to get this visualization of like a tree. You can actually scroll to the right if you do this on the, if you increase the max depth. And we also have the Column notebook, which is what we're going to use today. This is a copy from last week's notebook with a new name. So the one from Live 85 is frozen as it was when we finished that stream. All right, so we're going to take a look here. We have a write-up in progress. We'll do that later. And then we have also run TensorFlow in a Docker container. We might do that later. Okay, so I'm going to take a look at this as we did last time. So let's close these things. Let's let's just see what's in here in terms of the cells that have been executed, right? So you see this pip install TensorFlow Decision Forest, what we just said. Utilizer was, it's to do some magic in Colab logs so they don't get too long. We import dependencies, check what we have in terms of GPUs, the hidden, okay, so I think it might be this that uses the utilizer thing. Training a random forest model, and then we downloaded the dataset, visualized a few cells of it. Then we decide the label. I did some inspecting, so you can go back to live 85 if you want to get more familiar with some of the things that I did there to understand how the data was being manipulated. And I think that the highest, so the most important thing was that the pandas dataset is already setting the species by index, right? Like note how initially on the dataset the species are set by string, right? There's 3 unique strings for each of the classes or the species, right? These 3, and this code is actually already indexing those classes to 0, 1, and 2, right? You would have to do that separately with TensorFlow datasets if you don't get that from here, but that's already done for us. And there was a note here, right? Recall that PD data frame to TF dataset converts string labels to integers if necessary, right? So we get that sort of for free. And we got to train and read remarks, and then we evaluated the model. And I'm not sure if we saved it. Yeah, we saved it, and then we visualize here the decision tree and try to understand it a bit. Model structure and feature importance. I believe we might have read some of this stuff, but we probably didn't get to. Yeah, we saw this thing here and inspected a bit here. All right, so why don't we, so this was just a recap. So why don't we go now and rerun the entire notebook and see what is actually happening here. So first thing we're gonna do, just in case we can, we're gonna reserve a GPU for our notebook, and we're gonna connect so we get actually a notebook there, a Python runtime. And once that's ready, we can start rerunning some of these cells, because we're not gonna have anything on our folder or our cells, right? So again, as we did last week, we can see here the properties of the notebook that we have running, and I'm going to start running some of these cells. Okay, so we run that, we run this, and you can click here, or I can just select one of the cells and press shift return, right? So that will let me jump from cell to cell really quickly. So I'm gonna go up to where we were last week. Evaluate the model. Okay, so I think that's where we should be. And right now, yeah, so this is installing TensorFlow 10 and Decision Forest 1.0.1. And actually, while this is being done, let's go to PyPy and look at when this was released. So 1.0.1 was released in September 2022. This version was junked for some reason, and the pre-release was on August. So yeah, it seems like this library has been under development for the last year. So it's a fairly new library or initiative of this team. And let's see if this is actually getting to finish here. All right. This was okay. So this seems like it's installed now. So we also had Wordlizer. We have our dependencies. We have a GPU here. And we found the TensorFlow Decision Forest version 1. We have our data set. Note that there are some non-values. I guess like those get discarded. We have our classes. As I said before, we have our indexed data set. and there's some magic going on here. Probably converted it to an interactive table. Not right now. 258 examples in training, 86 examples for testing, and we train the model. The accuracy is 95%. Prepare for serving. Okay, so I don't think we want to prepare it for serving. Let me see. But yeah, okay, so let's save the model so we get it here in the folder. So this is saving it to temp. Let's go to temp. My saved model. And this is just a saved model in here. And we're gonna rerun this. So we didn't really kill these cells or like clean the output of the cells that we could have, right, in clear outputs. But this just regenerated here, and I'm not gonna go through this. We went through this last week. So if I do max depth 14, I guess this would continue generating to the right, but I don't think there's more. So yeah, okay. The root node on the left, blah, blah, blah. Summary. So these would help you understand what's affecting the most these the results, right, that we have. The input features, model 1 make inspector features. Summary score, build length, flipper length, mean. So with these things, you would be able to understand what affects the classification the most. Model self-evaluation. During training, the decision forest models can self-evaluate even if no validation data is provided to the fit method. The exact logic depends on the model. For example, random forests will use out-of-the-bag evaluation with gradient boosted trees. Will use internal train validation. While this evaluation is computed in training, it is not computed on the training dataset and can be used as low-quality evaluation. The model self-evaluation is available with the inspector's evaluation. Evaluation accuracy 97%, loss 0.09, mean square error, Gini. Okay, so on the book, on the hands-on machine learning book, let me actually open some photos that I had here. So decision trees are versatile machine learning algorithms that can perform both classification and regression tasks, and even multi-output tasks. They're powerful algorithms capable of fitting complex data sets. For example, in chapter 2, you trained a decision tree regressor model on the California housing dataset, fitting it perfectly, actually overfitting it. Decision trees are also fundamental components of random forests. See chapter 7, which I'm just going to read the overview of these chapters, which are among the most powerful machine learning algorithms available today. In this chapter, we will start by discussing how to train, visualize, and make predictions with decision trees. Then we'll go blah, blah, blah. Okay, so this is just like to get an idea there. And here what they try to explain, this is chapter 7 of the hands-on machine learning book for TensorFlow 2, in which they try to explain how these decision forest models, they use what's called the ensemble method, right, or ensemble learning. That is a phenomenon called the wisdom of the crowd. At the end of the day, it's like averaging or aggregating the predictions or the opinions of many different people, but in this case it's many different models. So many different models are trained, and they get assembled or like assembled into one. An example of an ensemble method, you can train a group of decision tree classifiers, each on a different random subset of the training set. To make predictions, you obtain the predictions of all the individual trees, then predict the class that gets the most votes, right? So it's like you're training many decision tree models, and then the votes get averaged or like added into the classification, right? So voting classifiers in some way. Okay, so plotting the training logs. Let's just continue doing this. This is just something that the notebook does to depict how you can inspect what we have done, right? So you can see here the loss. This is the accuracy, and we can even see this in TensorBoard. Clear existing results, if any. Export the metadata to TensorBoard. Start a TensorBoard instance. All right. So all of this is useful because this way you can copy parts of these notebooks and run them in your own data, in your own training experiments for other cases. And TensorBoard is loading here. One thing that I really would like to do is prepare a different data set and see what type of data sets can be used with decision forests, and try to train a decision forest classifier with custom data, right? So here we have the more detailed information. This is the accuracy. It's so depending on how much smoothing we apply, we'll go from what we saw before to something more elegant, let's say. And we have the probably here this is the accuracy, the loss, and I'm not sure we get to see the loss graph here. Okay, yeah, and this is the loss. So probably this does, I'm not sure if we set the steps or it does early stopping. So let's take a look in here. Yeah, okay, so training tree 300 or 300. Training of the tree fit data. We're not specifying how many trees we want to train, but maybe that is a method in the TensorFlow decision forests API. So we're looking at the random forest model here, and I just want to see the fit method. Steps per epoch. Okay, so we have steps per epoch, but we don't have steps. So I guess like the data set or some other data information will determine how many decision trees we're training. All right, let's keep going. So we wrap this up. Retrain the model with a different learning algorithm. Get all models. So this is gonna return all the models that we can train. So the random forest model, gradient boost trees model, card model, distributed gradient boost trees model. And if we go back actually to that photo that I took, then we will go through the card training algorithm used by scikit-learn, and we will discuss how to regularize trees and use them for regression tasks. Finally, we will discuss some of the limitations of decision trees. So again, I'll recommend the hands-on machine learning book. I'm gonna put a link to this book on Discord as well. So I note how I keep adding the links to this list. So this is hands-on machine learning. So I would like to also say, if you're online, please say hi on the chat. Let us know where you're connecting from. And this is, let me take a look. All right, so it's with Scikit, Learn, Keras, and TensorFlow. All right. Okay, so let's keep going. This gives us all the types of models that we can use. Help works anywhere. I didn't really know this. So you can get the help for a class, and then you'll get that help here. So let's actually try that. Help for TF, so just for Keras. Can we just do TF Keras? Help TF Keras. Oh, actually, yeah, it's working. So decision 4 is in a Keras model. Usage example. So we get the example that we saw before. That's pretty nice. Let's see if we can do help TF. Do we actually have that here? The primary function is to import all of the public TensorFlow interfaces in a single place. The interfaces themselves are located in submodels as described below. The init file, blah, blah, blah. Okay, yeah, nice. I didn't really know this help command worked. All right, so we delete this cell, random forests, we get the API here. This is actually Google trying to explain how all these things work, and how we can use all the algorithms. For example, here we have gradient boosted tree model. We get feature usage, name island. Let's see, all features. All right, so these, using a subset of features. The previous example did not specify the features, so all the columns were used as input features, except for the label. The following example shows how to specify input features. Note that the model is only trained with 2 features. It will not be as good as the one trained on all features. And this is what I like about this framework, right? That we are actually doing a lot in one line. So let me go back up. We have an entire training and evaluation script here where we just select 2 features by their names, set them in an array, and then have a gradient boosted trees model here. Features, all features, exclude non-specified features, true, and then compile with the accuracy metric, fit with the train and validation dataset is test dataset, and then we evaluate on the test dataset and return. All right, so let's actually run this training, and then the accuracy is 96. All right, so this was a lot faster gradient boosted tree model. As expected, the accuracy is lower than previous. Okay, so I guess we're getting 96%. So I guess if we deleted this, let's see what happens. In training dataset, training accuracy is 1. It might be overfitting. I'm not sure, but yeah, okay. So we're gonna run this as it was. All right, as expected, the accuracy is lower than previously. TFDF attaches a semantics to each feature. This semantics controls how the feature is used by the model. The following semantics are currently supported. Numerical, generally for quantities or counts with full ordering, for example, the age of a person, blah, blah, blah. Categorical, categorical set. Right, blah, blah, blah. All right, so Okay, so this is that you can specify certain um, features to be categorical sets, or numerical, right? So that's so you can customize a bit more what your model does. And then in hyperparameters, what I guess it's going on is that we are actually able to get some of the hyperparameters that work the best for our model. So let's say hyperparameters are parameters of the training algorithm that impact the quality of the final model. They're specified in the model class constructor. The list of hyperparameters is visible with the question mark collab command. Example, blah, blah, blah. Alternatively, you can find them on the TensorFlow Decision Forest GitHub or the YGG Dracel Decision Forest documentation. The default hyperparameters of each algorithm matches approximately the initial publication paper. To ensure consistency, new features and their matching hyperparameters are always visible by default. That's why it is a good idea to tune your hyperparameters. A classical but slightly more complex model. Growing strategy, best first global. Max depth 8 feet. A more complex, possibly more accurate model. Best first global, split axis, sparse oblique, categorical algorithm, random. As new training methods are published, an implemented combination of hyperparameters can emerge as good or almost always better than the default parameters. To avoid changing the default hyperparameter values, these good combinations are indexed and available as hyperparameter templates. For example, the benchmark rank 1 template is the best combination of our internal benchmarks. Those templates are versioned to allow training configuration stability. Example, benchmark rank 1 version 1, a good template of hyperparameters. All right. And here we can print the predefined hyperparameters. All right, and here what would make sense is if we actually evaluate the model, because otherwise we don't really know how they're performing. And let's just put this here, model 8, evaluate, return index. So we're gonna add the accuracy metric, and then when we evaluate, we now get is 98.8%. All right, so that is actually better than what we had before, right? Like I guess it's because of this benchmark rank 1. Let's actually try to remove that. And I will also say to the people who are watching online, you can say hi in the chat, say where you're connecting from, and also if you can hear me and you can see me okay. All right, so let's try. This is with the benchmark rank 1 hyperparameter template, and we're gonna try without that. So it's 97%. And if we go back to this one, we get 98%, right? So let me see hyperparameter template. DFDF Keras. So here I'm just searching for the hyperparameter values, and probably it's going to be good if I just copy and paste this value. All right, so if we look here, we have better default, benchmark rank 1. A configuration is generally better than default parameters will be more expensive. These parameters are winner take all. All right, so let's compare. So we have nothing was 97%, and maybe this is the default that is used if we don't specify anything else. So yeah, so it seems like that. So now we know we have those two hyperparameter templates, feature preprocessing, and I'm gonna stop here with the uh, decision forests. So we have feature preprocessing, and let's take a look at what this is. So preprocessing features is sometimes necessary to consume signals with complex structures, to regularize the model, or to apply transfer learning. Preprocessing can be done in one of three ways. Preprocessing on the pandas data frame. This solution is easy to implement and generally suitable for experimentation. However, the preprocessing logic will not be exported in the model by model save. Keras preprocessing, while more complex than the previous solution, Keras preprocessing is packaged in the model. TensorFlow feature columns. This API is part of the TensorFlow estimator library, not Keras, and planned for depreciation. This solution is interesting when using existing preprocessing code. All right, so I think these are the preprocessing layers. Yeah. So this means that we can add a layer to the head, to the top of our model. And every time that we put an input during training or during training. So for example, you can have preprocessing layers that get only applied during training and others that get applied during training, but also during inference, right? When you're predicting, for example, you want only to run random crop, flip, translation, rotation during training, right? And this is what they're only active during training. All right, yeah. So that I guess is the recommended TF Keras layers input shape, layers input blah blah blah. There's blah, blah, input raw inputs, output process inputs. And this is a preprocessor. So we're making a model that takes the raw inputs and outputs the processed inputs. So let's actually, all right. So what we're doing is we're going to use a Keras model with like a set of input layers and process outputs as our outputs, where we're going to add that as our preprocessing layer for our random forest model. And okay, and for the people who are online, I'd love if you say hi in the chat, and I'll say you can support the work that I'm doing here on the channel by liking this video and subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. All right, so where were we? So we have here the Keras. I like this experiment, right? So here we're creating a model with inputs, raw inputs and process outputs. And we have the input shape. It's just going to get a number that is the body mass. Body mass kilograms is body mass divided by 1000. Raw inputs. So this is the, okay, and build length. This doesn't really change. All right, so let's do one thing. So what we're gonna do, I'm gonna create a new cell here, and I'm going to, let's just run this code here. We're gonna print this body mass G. Hello, Juanda. Nice to see that you're plugging in online. I'm looking forward to seeing more of the things that you've done. I was thinking you could probably share it on during this season, not just on Discord, but on the live stream. And okay, so we have a Keras tensor, which is just created by layer body mass, right? So what I'm interested in is seeing what this body mass kg looks like. All right, so what we get is like a true division by 1000. I'm not sure. This is a bit hard for me to understand what's going on. All right, so when we create these raw inputs and raw outputs, right? These are just two objects, so processed inputs. So these are just two dictionaries. We have a tensor, this is a true div, and these are just numbers. So everything is just a number. So this is a number, this is a number, this is a number, but this is a division operation through a true div TensorFlow. Let's try it. All right, so this is a Python operation we're getting to doing here. Okay, and all right, so the next step is actually creating the preprocessor, right? So let's actually do some writing here. Preprocessor equals Keras model. The inputs, we can actually do this like this. The inputs are raw inputs and the outputs are processed inputs. So we now print preprocessor. We're going to get a Keras functional. This is just a model. And I guess, how do we pass things through the model? Let's just try. So preprocessor, let's actually do this. All right, so this is a type functional and get config, whole model saving. All right, so can we actually predict? Expects two inputs, but it receives one input tensors. All right, so let's say we just do 1, 2, 3, 4. Two inputs, we receive one input tensor. Input received. Predict. Maybe int and list. Okay, so let's take a look here simply with let's take a look here. So we have the inputs and outputs, Keras model. Let's just take a look at this. Inputs, okay. It's called call inputs. All right, fit. So what type of data do we need? So we call predict model. Okay, let's do one thing. Preprocessor dot summary. All right, so we have this non-one. Input layer, one number parameter connected to how do we preprocessing? Let's look for this. So Keras expects let's try simply so it has two input layers. So let's try to do Keras input, Keras model input, multiple input layers. Okay, so we got an input layer here. All right, so I'm going to simply, I'm not sure, maybe it's just like I'm trying to make it more complex than it has to be. That's it. Okay, I got into a rabbit hole. I don't know how to I don't know how to solve this right now. We'll see. Train a regression model. So this is a different problem. Featured columns. All right, now that we're here, so let me see. So we have two inputs. Not sure if I can do this. Syntax error. Failed to find data adapter I can handle. Dict class, string, blah, blah, blah. Okay. So I need to predict with something here. And if I put X, I'm not sure what X is expecting. One input tensor. So this is this one input tensor. Hmm. I can't figure this out right now. So, okay, one more. Keras model, specs to. TF. So, how are they doing it? So, can I. All right. Okay, so it seems that we need to see how the train.ds was created. So at least I got something here. Prefetch dataset, which has all the items. This is 3.8. It's like grams, right? Kilograms, and it was grams before. So let's say we do this just for verification's sake, the number should be smaller. All right, so this is working. Let's see how train.ds was actually created. Dataset df. Data frame to TensorFlow dataset with label. All right, so it's basically that you need to input a dataset. All right. Okay, so I've learned something. I need to figure that out a bit better. But yeah, so this is it for the Palmer's Penguin dataset. If we go here and clear all outputs, I think we're going to be able to understand this slightly better. I'm not sure how much better, but slightly better. And yeah, I mean, I think I get it. They're like reading the data set, and we get a dataset df or data frame, which is what we're visualizing here. And that gets converted. Well, this is splitting into test and train, and here we convert those into train ds and test ds, which is two datasets with those properties in TensorFlow world. Okay, that's good. All right, so let's take a really quick break, finish with this, section and move on to the next one. So let me actually, if we can download this, if I can download this to a new collab. Maybe what I'm gonna do, so not to confuse people, we haven't done anything with the app alone. So everything below here, I can actually remove. And this one. All right, so I'm gonna leave this. The link is there. I'm gonna put this. Well, it's on Discord already. And what I wanted to do, I'm gonna try. It's okay. Let's create a new notebook. New notebook. Okay. Okay, let's quickly see if we can make a really tiny Keras model that is meant to pre-process our data, just to manipulate data, even if it's just to pass it a set of numbers and divide them or multiply them. So first thing I'm gonna do, I'm gonna import TensorFlow as TF and import pandas as PD because we're gonna read a CSV. We're gonna set this runtime to GPU. We're on Google Colab, so that's a colab.research.google.com. I'm gonna connect my runtime. I have another notebook here, so we have two sessions. I'm gonna kill the other one that I have, and I'm gonna close. So now we're gonna connect here. I'm going to use some code that I have here. So this is just to verify the version that we have of TensorFlow and whether we have a GPU. So I'm just gonna run these two code cells and we'll be verifying the TensorFlow version that we have. All right, so we have 2.9.2, Python 3.7, and we have a Tesla T4 GPU. My name is Nono Martinez Alonso. If you're enjoying this video or others on the channel, please like this video and make sure to subscribe and click on the bell if you're gonna get notified when I go live next or when I upload new videos. All right, so we're gonna get some code from here. I want to take a look at this CSV file. I'm gonna download it to my local machine, not just to the notebook. So I'm gonna make this bigger so you can see it. And we're just gonna download this to the desktop. So I'm gonna change this directory for my desktop. And we don't have wget here. Let me see. All right, so it seems like we are able to do that, and we do have that. So we're gonna take a look. So this is our CSV. Actually, probably prettier if we take a look with max preview. This is the CSV that we have. So we have a set of header columns that define the name of these features, and then we have a set of samples here. For each of those features we have a value, or maybe we have a not a value. All right, so this, now I'm just going to make a copy, and we're going to put here sample, because we want to edit this. We're going to edit this with Visual Studio Code locally. And let me see, so we're going to make a data set that is going to be people. Let's people. Let me take a look. So let's actually just put people, age, born. So to continue the same format, okay, and this just put here no 32 990, and we're gonna put here Peter. We're gonna make up stuff here 50. Okay, so these actually, I guess, like just these are correlatives, so we don't really need that one. But okay, so we put like 14, and we put just like, I'm making these things up. Okay, all right, so this is our data set, and we can preview it here as well, right? It's really dumb data set, but that's what we got here today. And this is for life 86. I'm just gonna put these things here, and I'm going to drag and drop to my Colab notebook. So I'm gonna take a look at the file. It says I have too many sessions, so this is the wrong notebook. All right, so we're going to drag and drop this penguins.csv file here. It's gonna tell me that it's actually a sample. It's gonna tell me that the runtime will wipe all of my files once this notebook runtime is closed, and we can visualize this here as well, right? So we have our CSV. So the first thing we're going to do, just going to read that CSV with pandas, right? It is really a one-liner. So we're going to do here is load dataset, load a dataset into a pandas data frame. And how do we do that? So we simply say a dataset data frame PD, and then we simply read CSV with let's actually do here pwd to see where we are. Content, so it's going to be at content sample CSV. All right, and we print our data set here, so we see that that's working. All right, so we have our data set, and we can, I mean, we could display the first samples, but really we don't have so many things there. But whatever, let's actually just do the head 3, because that's what display the first 3 samples, and we just show that it's the same. But if the dataset was larger, we could just render a few. We're getting this index here, which we didn't add, it's just the number of the column. And here they're trying to classify by a class, so we don't have a classification task or anything. We're just testing here with a data set. So we're just going to jump into here. So TensorFlow data frame, Keras, pandas data frame to TensorFlow dataset. This actually, I didn't remember, I guess, that we were requiring this TensorFlow decision forests dataset to get from a data frame into a TensorFlow dataset. Because what I really wanted to do is define a TensorFlow Keras model preprocessor. So how we did this in another exercises, we just define TF Keras layers input, and then we put here the shape and the name. As you can see here, so the shape is just going to be a number, and the name is going to be, for example, age, and then we would have another one for birth year, and we put those here, birth year and age. And then our raw inputs would be, we just have to put here age would be age, and birth year would be birth year, and the process inputs would be age in days, for example, right? Something like that. And we need to create this as well. So we have to create these ones, and these ones would be simply the age multiplied by 365 and the birth year multiplied by, or like this would be 2022 minus the birth year, right? That would be our input and our outputs. And we would have to simply create our preprocessor of data that is going to be a TensorFlow Keras model with inputs and outputs. The input is going to be raw inputs, and the output is going to be processed inputs. And I think that's it. And then here we can do preprocessor.summary. And then we get a definition that we have these two inputs, and then we have these two outputs, which is going to multiply the age and subtract the birth year. And what we could do is just pass age and birth year and values and get back the results. So we're making a model that just makes those operations, in this case simple operations like multiply and subtract. The thing that I was struggling with is like how to convert this data frame into something that we can input to the model. And let's actually see, create a TensorFlow dataset from a pandas data frame. Download CSV file, read CSV file. All right, the types. Okay, let's actually take a look at the dataset. Oops, dataset df d types. All right, so we have twins, one object, and here pop target. You will build model to predict label and target. So we pop in that data frame as an array, numeric feature names. Numeric features. And I'm not sure if I was doing it right before. And I just need to do TensorFlow convert to Tensor. Let's just try here. Preprocessor predict. This is actually doing everything. So let's actually just create another cell, predict, and I'm going to do here TensorFlow TF convert to Tensor this. All right, so this is the same rabbit hole I got in before in a previous video. So what I'm going to do is, let's see, so we have this here, convert to tensor numeric features. Okay, let's try this to do this. So we're gonna try doing okay, so numeric feature names are age and birth date, and here we get dataset, data frame, numeric feature names, and we comment this out. Let's see what we get there. Birth year. Okay. TensorFlow convert to tensor dataset numeric features. All right, what about simply putting here numeric features? Right. Not sure how this is to be, but actually I just realized that this column should be called name, not people. So we can re-upload there. Right. And here we'll do string features, target, and we get this. Okay, and the target, I guess, is string target. Right, let's see. All right, none of index name. Okay, we gotta load the this thing again. So it says name now, and then this works. So let's see, numeric dict dataset. All right, now this has age, birth year, and then the target would be somewhere I cannot see. All right, so let's try to see if I can input this now. Numeric dict, yes. Yay, okay. Nice. All right, so these took really long, and maybe we should redo it again. I could redo it later, but I'm gonna recap now what's going on. We have 3 people in this data set, and we can see them maybe by here. What's happening, right? Where we got to is that we're getting these 3 values, which is 32, 50, and 14, multiplied by 365, and these 3 values, which is 2022 minus the years here. So for example, my age is 32, 50, and 14, that was the age of that we were setting in here. And then if I get, for example, 32 by 365, that is the amount of days in my years or in my age. So we had to do some sort of complicated conversion here, I would say, but we managed not to use TensorFlow decision forests for this, which was just a one-liner, but we didn't have to. And what we did is that we've made a model that now infers these subtraction and multiplication operations, and the model is defined as a TensorFlow Keras model that gets inputs and outputs, right? And that's nice because now we can, I could go and edit this and add more people here. We can put this as like something like this and put here. This one is a bit dumb because it's basically just calculating. It could be inferred by the date but anyway, that's what I did. And now that that has been replaced, I would go into run all. And what you can see is that at the end, now we've also processed that in 5 years, we have 120, 1800, so 1825 days, and that the age is 5, right? All right, so this was an interesting exercise, I think. And what I'm gonna do now is that I'm gonna get the shared link for this notebook, and I'm also gonna paste it on. So first I'm gonna paste it on the Keras pre-processing model on the chat of YouTube, and I'm gonna paste it with the links for decision forests, Palmer, Penguin, classification, and then we have here this one that is Colab notebook for Keras pre-processing model, which is here. All right, so we keep adding things that we're using during this session. And now, as I said, so let's take a quick break. So I'm gonna hide myself and I'm gonna let you with a break slide, and we'll be back to do more stuff in a bit. All right, we're back from the break. Not sure what's going on with Keynote right now. Just close it. All right, so let's just close that. Okay, so we've done this exercise with Keras preprocessing. We've finalized looking at the decision forests notebook, and we have these two files here, which are not super important, I would say, but we'll keep them with the rest of the things. And now we're gonna take a look at two different sets of things. Not sure we're gonna have time for TensorFlow signatures, but we will definitely take a look at some Docker stuff. So in preparation, I'm just going to make sure that Docker is running before we get started, and it seems like it is. All right, so this is Docker, images and containers, and that I have my, okay, so we actually need Keynote now. I have my terminal, and we have here live 86. Great. All right, and as always, I do record these things having in mind that I might upload them later as a separate video. So that's why I will be repeating the thing of subscribe and like and other things alike. All right, so let me actually go online on Twitter. We're gonna share here that we're doing this live in case that anyone cares about. Okay, enough for that. Let's see how that shows. All right, worst layout ever, but it doesn't matter. Okay, so let's get started and do this. Let me actually do one. All right, let's go. Hi everyone, it's Nono here, and oh wait, one sec. I'm actually gonna move this because otherwise it's impossible for me to move my fingers properly in here. I'm gonna move this thing here. Okay, We start again. Hi everyone, it's Nono here, and this is a quick video on how to run TensorFlow inside of a Docker container. Make sure that you like this video and subscribe. All right. All right. Google Home. All right. Google Home somehow is interacting with me as I'm trying to record it. All right. Once again. Hi everyone, it's Nono here, and this is a quick video on how to run TensorFlow inside of a Docker container. Make sure to like this video if you would like to see more content like this one, and to subscribe and click on the bell if you want to get notified when I go live next or upload new videos. So if you don't know what they are, Docker is a program that is cross-platform because it was built with Golang. This is a programming language developed inside of Google that is really performant for backend services and even desktop applications. So that allows us to virtualize machines, like, for example, a Linux machine with a different runtime than on your machine, and a different set of dependencies and programs and things, in a way that we can run programs that run inside of Linux, even if we're in a Mac machine. And we can grab something that is called an image and have a lot of pre-installed things on the system just by downloading like a big file, maybe like it's like 80 megabytes or 2 gigabytes or something. And TensorFlow is a machine learning framework developed by Google, which is one of the most widespread and most widely used, but it's not always easy to install it on your machine. For example, in Apple Silicon Macs, it's not supported by default, and there's some workarounds that you need to do to get that going. So the idea in this video is that just with a few commands or even with one line command, you're going to have TensorFlow running in Python inside of your Mac or your Windows by running inside of Docker. All right, so this is the minimal code that I could prepare to get this up and running, right? So here we have 3 commands, which can be actually combined into just one. The first one is docker run -it python 3.9 bash, then pip install, and then a Python command line execution of a command, right? So let's go step by step into what each of these ones mean, and you'll see these things appear in this side of the screen. I'm going to first tell you, we have here docker run it. So at the bottom of the screen, you can see that the I flag means interactive. So we are going to keep like a session open in bash on the terminal. So we're going to be able to interact with a bash command as if we were connecting to a remote server or to a terminal on our computer, but it's that virtualized machine. And the T is for allocating a sudo tty that honestly, I don't know what it means. Then we have Python colon 3.9-slim. This is actually the image, the Docker image that we're pulling, that is going to be mounted and actually running in our container. What this means, or everything you need to know, is that Python 3.9 is going to be, or light version of that, is going to be installed into the container that we can create, that we're going to create with Docker. And then we have bash. Because this is going to be interactive, the bash command is going to get executed on that instance, and we're going to have an interactive session. We're going to be able to continuously use and prompt commands to that session, right? Moving to the next command, we have pip install. Pip is the package manager of Python. You can also run it with python-m pip and then install whatever. And here we install TensorFlow, which is TensorFlow core, the core library, and then TensorFlow IO, which is also needed for certain operations. Then for the next command, we have Python. If we run Python and just press enter, we'll get what's called a REPL, REPL. That's also an interactive session in which we can prompt enter Python commands or Python code, and actually will get executed or evaluated as we press enter. The difference here is that with the -c, we're actually going to pass a command, a set of code, and it's going to get all executed and it's going to return. So we're not going to have an interactive session. There we're calling some Python code, which, as you can see, is importing TensorFlow STF, then printing a constant value in TensorFlow, and then converting an array in Python to a tensor. Then you get the output that you're going to see here. All right, so without further ado, we're going to do this on our terminal. All right, so that I need to edit, and we're going to move now into our terminal. Okay, so this so this is our terminal, and what I was showing before, you have this docker run it python, right? So let's just issue that command, docker run it, and here we do python 3.9/slim, and then we do bash, right? If we just do this, if we just run this command, we're actually just getting the default entry point for this command. So let me actually see where we are. Okay, so we just get the default on that Docker image. As I do this, as I issue this command, if we go to Docker, you can see that we get this inspiring Bahaha and nifty write created, right? These Docker containers, right? That's the concept of our container. So if I actually resize this so you can see it, every time I exit this container, the container turns from green to gray because it exits, right? You can see that here, exited. If I run the command again, I'm going to click here. This is going to create a new container, and we can either pause it from here. Let me show you that that gets closed at the same time. Closed. Okay. So we're going to close it from here, and then our container is busy, and hopefully we'll kill it, but not sure if that's going to happen. So I'm just going to kill it from here. All right, and that exits, right? So we can kill these things by hand, but one nice thing that we can do is that we can add the --remove command, right? So now we have this interactive Python REPL here, and as I exit, this command is going to disappear, get cleaned from Docker. That's a lot better, because if you just want to do some Python code here and exit, you don't want that container to stay there, right? You can imagine that if we don't do that, we're gonna start doing this and accrue a lot of debt there in terms of how many containers we'll have there. All right, so that is for this command, right? That's the default of this Python image. It probably has, and we can actually go into the internet and actually look for that in Docker Hub. We're gonna look for that image, and we're gonna see if we can see the image definition. We might not be able to. Yeah, okay. So what this means here, this last command, is that once this image is used to instantiate a container, the cmd python 3 is going to be executed, right? We actually can see all of the steps that are executed here for to create this this image, right? And that can be avoided in some way if we provide the command that we want this instance to generate. The default is Python 3, right? So we're gonna get the same thing that we were getting before, and we can replace this with bash or bin bash. So we'll just do bash, and now instead of a Python REPL, we have this bash console where I can do ls, I can do pd, and I can actually go into these directories and execute commands that belong to Python. So for example, I could do Python version, and we can see that that's the version that was running on the runtime. All right, so enough for containers here that we have to remove manually. So what I'm gonna do is that I'm going to add that remove flag here. So every time I go into my Linux machine and I exit, that gets deleted. Another thing that you could do is you can specify a name, so nonos container, and that way you know which container this is in here, right? I could actually try to exit that from here, but every time we have an interactive session, that doesn't like it too much. So we've seen that I can create a container. And when I, for example, go to my user folder and I can create a file, for example, file.txt, we have this file.txt file here, right? If I exit and I go back again, when I go to my user, that file is gone. So what can we do to solve that? We can actually keep, now that we have a name on it, we remove the remove flag, and now we create that container. So we have nonos container and we exit. That container actually stays with us. So I can start it here, and now instead of docker run, I could do docker exec, so exec of execute iteratively, and we're gonna do, let me see, I think I may put this here. So we're gonna do exec nonos container bash. All right, so I forgot how to do this. Let me see. I don't remember how to reattach there, but I think if I just put here, all right, so that works, but that exits. So what I'm trying to do is to reattach here and not have to remove the container. But anyhow, what I'm gonna do is I'm gonna actually remove this container, and I'm gonna do what we said we were gonna do, which is we're going to run TensorFlow, install TensorFlow inside of that machine. So we have this here, right? So all we have to do is that I'm gonna go into here, I'm gonna do that command that we had before, and I'm going to now do, because I have pip installed, I'm gonna do pip install TensorFlow and TensorFlow IO. So we run this is gonna install our TensorFlow dependencies and TensorFlow IO dependencies inside of this machine. It's installing TensorFlow CPU, the AWS version. That's interesting, I hadn't seen that before. And now what we can see, let me actually see why this stays here. Let me just close this and remove this. All right, great. So now we just have to try to see if Python is actually installed. And there is a handy command here that is fairly easy, and I've actually posted for you online, so you can directly go to nono.ma/TensorFlow docker, and that will take you to this post with exactly that code. I'm going to write it by hand. So here I could do Python 3 and I could do import TensorFlow as TF. So I have an interactive session, as I said before, where I can print things like TensorFlow's version. And I can also do TF tensor. So let TF constant 42 and TF convert to tensor, and we can get here like an array, right? So this seems like it works, and we also have TF Keras. We can create a TF Keras layers input shape 1 and name my layer, right? So we could do this type of thing, and we could, I don't know, we could do a model. We could even do a Keras sequential, I think. Yeah, right, and make a summary. All right, so what this means is that we have TensorFlow running inside of our Docker container, and if I go to Python 3 in my machine, that doesn't exist, that model doesn't exist. But inside of this container, the nonos container, it actually does exist. So we could actually say docker exec in nonos container, and we could do Python 3 and then import TensorFlow as TF and then print the TF version that you have there. Let's see if this works, right? And we're getting that. And we could let's make this a bit clearer. So we could, maybe we just do this. So we could do any other thing, but I mean, the easiest thing we could do is execute Python 3. Let me see if I can do it interactively. Let's see how we can. So docker exec help. Interactive. So where do we put that command, that interactive part? So probably just here, right? Okay. All right, so that worked. I don't know if I did it differently before, but we could just execute from here Python or Python or bash, right? So we can just do docker exec interactive nonos container bash, and then we have this, and then we can do docker exec it nonos container Python 3. So maybe I have to go back on the video. Maybe I just had a typo there, but anyhow. All right, so what I'm gonna do here is I'm going to, so that's a wrap, right? Like this is what I wanted to show, and I think I'm just gonna do it again, just record this tutorial again, but a lot faster because I can, yeah, now I have a lot more fresh. And I'll see if I release this or not. All right, once again. Hi everyone, it's Nono here, and this is a really quick overview on how you can run TensorFlow inside of a Docker container on your machine, regardless of whether you can install Docker. Okay, let me get back. That was a mistake. Hi everyone, it's Nono here, and this is a really quick video on how you can run TensorFlow on your machine inside of Docker, even if TensorFlow cannot be installed with pip or with Python on your machine, right? For newcomers, people who don't know this, Docker is a program that lets us virtualize Linux machines and other types of machines in our Mac or Windows. And TensorFlow is a machine learning algorithm, a machine learning framework by Google, which if you're here, you probably know already. All right, quick reminder, please like the video if you would like to see more content or you enjoyed this video, and subscribe and click on the bell if you're gonna get notified when I upload new videos. All right, really quickly, I'll tell you what you need to do, right? We have 3 commands here. The first one is docker run it. So docker and run basically just runs a new container using an image that you give it. Here, the important part is the I flag that is going to create an interactive session for us. You have here Python 3.9 Slim, which is the image that we're going to use on our container, and we have bash. So we start an interactive session. When we have the interactive session, we'll be able to run pip install TensorFlow, TensorFlow IO. This is TensorFlow and the TensorFlow IO package, so I can then run the Python command that I have in the code, right? All right, so let's actually take a look at how to do that. I have a window here, and I also have Docker. If I run here Docker run interactively, and I select the Python 3.9 Slim image, I'm going to say I want to start a bash session, and I'm going to actually name this TF, so we know what container we're talking about. This gets started really quickly. I already have this Python image on my machine. In yours, you might have to download it. And we can see here that indeed we have that new container that has a Python image called TF here. We could stop it or we could do whatever. When we exit, we'll see that this actually gets stopped. How do we get back to it? If we get stopped, we click play. We now run here docker exec it, the name of the container, and then what command we want to run on it. All right, so we're back on our container. Now I can check here that I have Python 3 and that I have pip, and we're gonna straightforward do pip install TensorFlow and TensorFlow IO. This is gonna take some time, and I'm gonna explain a few things here. This is installing TensorFlow not on your machine, but on a virtualized machine that is actually a Linux machine. Indeed, you can actually see that it's installing TensorFlow CPU AWS. That's a specific build of TensorFlow that is meant to run on cloud instances, probably on AWS, right? That's Amazon Web Services. After all these packages have been resolved, pip is installing them on that container. Remember, this container is running in this Docker container, and if I delete or stop that container, TensorFlow is like, it's not installed on your machine anymore. If you don't delete the container after stopping it, you can connect back to it and continue using TensorFlow. All right, so it seems like that's done. So I'm gonna click here on Python, verify that the same Python version is present if I just do Python. So I'm gonna go into Python, I'm gonna import TensorFlow as TF. We're gonna first print to see what TensorFlow version I have. And now we can test a few operations here. So for example, TF constant is gonna return a constant, and convert to tensor with a simple Python array is going to return a tensor shape 30. All right, I think this is it. So this was Nono Martinez Alonso with a really quick video on how to run TensorFlow on your machine. Remember, you can like this video if you want to let me know that this was something useful for you. And don't forget to subscribe and click on that bell if you're going to get notified when I upload new videos. For those of you who are still there, I'm going to show really one quick thing that clarifies everything, I think. If I exit again, Python and the container, you can see here that that container is still running. I can stop it. So we can stop the container. We can reattach to it, and I'm back at it, right? But what happens if I now try to use my Python version of my Mac and try to actually do that? So TensorFlow as TF. So TensorFlow is not there. So what do I have to do? I just have to do docker exec interactive, go to my TF Docker machine, and I can directly run Python 3. All right, and we forgot to put this here. So let's scroll back. All you have to do is run docker it exec, the name of your container, and then you can go directly to a Python 3 repo. I don't know what's going on. All right. All right, I'm inside of a Python repo already. All right, back to the real world. And all that you have to do, let me put this really big so you see it. And actually, all that you have to do to get back at that container is first start it. And now we'll just do docker exec. We can put here, okay, let's actually do it once again. Actually, all you have to do there is you get your container running is docker it exec tf, and then we can directly prompt the Python 3 command to get a repo. Okay, that wasn't running. Right, once again, all you have to do is to actually just run docker exec tf with it for an interactive session, and then call Python 3. All right, once more. So we're gonna close this. I could have stopped the video there. All right, if anyone's still watching. All right. Okay, all you have to do is go back to your container, start it, and once that's started, you just run docker exec interactive, the name of your container, and then you can directly prompt the Python 3 command to get a Python session. Here we'll have TensorFlow as TF, and you can see that that's being properly imported. All right, it was Nono Martinez Alonso here. Thanks a lot for watching, and I'll see you next time. I'm actually, now that I'm here, I might actually record that again just to make sure that I get it right. Well, I think I'll just edit that one because it's okay. We don't have to spend more time on that. All right. So the last thing that I wanted to do, right? So it was talk a bit about TensorFlow signatures. I haven't tried this, and I really want to learn a bit and see how they work. It's a bit similar to what we did before. All right. So, okay. So this is, we're going to take a look at TensorFlow signatures. I haven't really worked with TensorFlow signatures in depth, but they apparently seem really useful for TensorFlow Lite models. If you want to export a model or maybe any model, so you have different operations like encoding and decoding or predicting or like doing some pre-processing, you have different operations. And we have this concept normally that if you export a model, that model is just going to be able to classify, but maybe your model can do different tasks like encoding, decoding, or generating, or classifying, right? So this link that I put here is tensorflow.org/lite/guide/signatures. I'm going to open that from the Discord server, so you can join another mass Discord. And we have this, have I put the link here? If not, I'll put it right now. All right, so TensorFlow signatures. Okay, we'll put this here. Yeah, so we have a lot of documentation here, and convert a model with signature from same model, Keras model, concrete model. And the idea here is that they're telling you that this is meant to be used for TensorFlow Lite. And, you know, I have some slides here that we could see. So the thing here is that you define your model. So this is a custom class model that it's a subclass in TensorFlow model. And you actually get this TF.function decorator for the def encode. So that's the encode function, and this other decorator function, TF function for decode. Those two decorators tell the converters and TensorFlow what these two functions are and that they have to be exported as different signatures, right? You have your input signature there and input signature here. This is a float, this is a string. And I haven't done too much, but TF strings to number, strings as string. And, you know, all that we're doing here is that the input here is strings as string, strings to number. So we're getting here like a string and here a number, but we're getting a different result, right? In here, we're converting to number, here we're converting to string. So this is encoding a number into a string, and then here decoding a string into a number. And that's kind of the two operations that we're able to do in here, right? So there's code here, and there is as always, like there is a Colab notebook. I don't personally like to teach in this way, but due to like not having prepared too much for this and just wanting to explore things with you, like be able to just learn as I see these things, this is what we have right now. So TensorFlow Lite supports converting TensorFlow models input output specifications to TensorFlow Lite models. The input output specifications are called signatures, which can be specified when building a safe model creating concrete functions. Signatures in TensorFlow Lite provide the following features. They specify inputs and outputs of the converted TensorFlow Lite model by respecting the TensorFlow model's signatures. Also allow a single TensorFlow Lite model to support multiple entry points. That's what I meant before, right? These entry points could be you send it an image and then it generates something, or you send it a vector and it generates an image, right? So you have the possibility of thinking out loud to make any function into your model that TensorFlow supports. The signature is composed of three pieces. So you have inputs, outputs, and signature key. The inputs map for inputs from input name in the signature to an input tensor. Outputs map for output mapping from output name in signature to an output tensor. Signature key is the name that identifies an entry point of the graph. That's what we saw before as encode and decode. So the inputs here we saw could be, for example, a string tensor or like a number tensor, and the output could be a string tensor or a numeric tensor as well. So let's get to run these cells and see what happens. So we import TensorFlow. We've seen this before. We define these two encode and decode functions. We convert the model with signature, so we get our model. We instantiate a model of our class, right? Like this is the model class that we're defining here. And we go here. Okay, so let's see, we've run that. Let's also run this cell here, save the model. So we're gonna save the model to content, save models coding, then TF save model save. We're gonna save it there, our model and our signatures. So we do model encode get concrete function. Let's see what we get when we do, we have that here. So we create another model, model to, can we do summary here, or if we haven't compiled it, doesn't work. Okay, so it doesn't have that attribute. It's a TF module. It's not a model really, but I don't know what the difference is. So here we could return the encode concrete function, which is what the model signature is getting. So it's getting a concrete function, and that's what the model signatures require. So we convert the save model using TensorFlow Lite converter, targets supported ops, TFLite built-in, select TF ops, enable TensorFlow operations, enable TensorFlow Lite operations, TensorFlow Lite converter convert. Print the signature from the converted model. Interpreter, we load that model with the TensorFlow Lite interpreter, and then the signatures. Interpreter gets signature list, print signature. So we have decode, input is X, output is decoded result, encode in input is X, and output is encoded result. So decode and encode, and you can see that they're sorted by alphabetically. Generate a Keras model. So we actually generate a Keras model here. Keras model. This is like a neural network, supposedly. It's like really, really small thing. Convert the Keras model using TensorFlow Lite converter. Same thing we've done before. And then the interpreter, signature interpreter signature list. Where have we specified those? Here. Okay, yeah, so this is the serving default. So this is when you export a TensorFlow, like a Keras model, you have the serving default, which is gonna be the, which is gonna be just serving default. It's like if you're gonna serve this model in the cloud, you just want to get the X input and then get an output, right? And yeah, so this is, for example, here we have dense input dimension. So if we were to here do Keras model summary, I might be able to I might be able to do Keras model predict with a, what is this? Whatever, it's just giving us a number. Concrete functions, run signatures. Okay, this is the important part, right? Like in Java or any other language, I'm gonna ignore right now Java and C++, but this is the cool thing, like you could actually use the encode function in C++, right? So here we load our interpreter. So this is, we load our TensorFlow Lite model. We print the signatures from the converted model. So signatures, interpreter get signature list, and then encode and decode are called with input as arguments. So encode and decode input TF constant which is pretty cool. Encoded result, it gives us an array of binary strings, and then we use that to decode it back. That's pretty cool. I mean, this is really nice. And as TFLite interpreter doesn't guarantee thread safety, the signature runners from the same interpreter won't be executed concurrently. Support from C, iOS, Swift is not available yet. Version 2, the multiple signature features implemented. All the converter APIs from TensorFlow 2 generate signature enabled native TensorFlow model. Signature feature available from same model converter API. All right, so this was the overview of what I wanted to see. So we've seen TensorFlow signatures today, and I hope that this was useful if you've watched it. So that's pretty cool. And I think I've put that link here as well, right? Yeah, TensorFlow Docker. Okay, so we now can close our, or even delete our container. All right, so I'm going to move this folder. Okay, that's a wrap. All right, so I see, I don't know if there's anyone connected at the moment. What else could we do? Have I learned anything different with Docker? I mean, the one kind of like a really nice trick with Docker now that we're here. What I really like is, let's take a look. So if I do Docker run and press up, I'll see. All right, so let's just do remove here. So the container I create after I exit, they get removed, right? So I think I can do container ls, so there are no containers. And if I don't do this and say name my lonely container, right, I can exit, but that container still exists. Oh, it's not there. Not sure why. Should be there. It's here. Not sure. Maybe it only shows the running containers. Okay, so yeah, it only shows the running containers. So yeah, I put the remove flag in there, right? No name, just a remove flag. And the one thing I wanted to show is like, if I just do this, right? If I just do bash, or like actually just do Python 3 print 3 plus 4, just having Docker on your machine, you could run this command, execute any Python code without a need to have anything else installed, right? So you can imagine what we did before, like import TensorFlow, which is not available here, of course, give you an error, but I'm just running the Python code somewhere else. Like I'm not having to, I don't have Python, I don't need to have Python installed on my computer to be able to run these things, right? So you're just saying Docker run, remove this after I go, interactive session, Python. And what's really nice, for example, I can get a Linux machine and I can learn things about Linux. For example, the size command, oh, here, right? I can use this as a Linux machine. We can see many things here. All right, so that's it for today. Any announcements? All right, so let's go through some announcements. Getting simple podcast. So we actually have released the this how to start a podcast conversation. So this is me and Steve, and we cover many things, going from like motivation, recording and editing, guests, building an audience, long form conversations, evergreen content, monetization, many things that are on my mind and questions that he sent my way that we discussed. And let me know if this is interesting, or as I said before, you can submit questions to gettingsimple.com/ask about these or any other topics, and I'll be glad to discuss them there. All right, so thanks everyone for watching. Once again, I'll say please support the channel by liking this video and subscribe and click the bell if you want to get notified when I go live next or when I upload new videos. This really helps. We're actually trying to get the channel up to a point where it can be monetized through YouTube, and that entails getting to 4,000 hours of played, so 4,000 played hours in within the last 12 months, right? So that's like, they're like hours from the former like days that are just a little bit away from 1 year that get to disappear from there. So it's like you just have to increase your average minutes. I do have actually, if you go into my site, let me see if this is let me see, how to monetize YouTube, I think it's the name. Yeah, so how to monetize YouTube is a post that I have on my website, and that actually talks about how the requirements for you to monetize in YouTube, right? So I was at to 2,666 public watch hours back here and 1,300 subscribers. Now we're getting better, and this keeps growing. I think I'm up to almost 3,200. So we have 800 public watch hours to go for that average to go up, and we might be there pretty soon. And yeah, some other announcements that I could do is that we're also editing an interview with Sacron and other people on the podcast, but Sacron's probably gonna be the one that goes out the soonest. So let me see. Yeah, so here is, and I'll hide myself. Here is a video test. Hopefully audio from here is plugged. Let me see. You gotta take care of everything. So there is a point that even if you care about everything, it's so controlled that you can let it aside.
Yeah. No, at some point, I decided on 12 by 18 drawings. as you see on the wall, of just like, that works. I'll work with that for a while. And then it becomes a lot easier. Like, okay, I know I always have paper. I know I have.
And yeah, so that is one of the tests that we did. And I think in here, in here actually we also have another example that is multicam. So let me quickly show you that one. Yeah, so the difference with this one is that it's this recording is actually multicam. I actually didn't realize, but this feed is 4K and the other camera is 1K. But yeah, let's play it just so you can see like a sneak peek.
But for the evolution of this podcast, it seems like if you had stuck to, this is what it is about in 2017, 2018, that'd be really weird if you were still doing that. Like, you have changed dramatically. Your whole environment's changed dramatically.
Okay, yeah, so that's it. I have here the typical thingy, but all right. Thanks a lot for watching, and we'll see you next time. Bye bye. And don't forget to leave any comments on Discord or on these videos comments, letting me know if you like anything specifically, or if you would like me to cover any other topics in case that we get the time. Bye bye. Thanks a lot for watching again. I'll see you next time.